Welcome to 25th lecture on ECD, Electronic Circuit Design. In the last lecture, we studied class AB push-pull amplifier with single power supply, VCC, and this is ground, and these two diodes are used to avoid crossover distortion. We studied in earlier lectures. But the last disadvantage that we studied in our last lecture was that the Rin, the input resistance of this amplifier, is very small. So it's not good. If it is being driven by another amplifier, it will load that amplifier because of having low resistance, low input resistance. Because the input resistance for this amplifier, we studied that to be R1 in parallel with R2 in parallel with this beta times this small Re plus this RL. Since RL is very small, Re is also small. Multiplying them by beta doesn't make them a large value, and therefore the equivalent Rn is a small value. That's not good. Of course, that's not good. That's not desired. Why? Because it will load the amplifier that will be driving this amplifier at its output. So it will load the preceding amplifier. So therefore it's not good. So how to combat this problem, how to address this problem? There are ways to address it, and one of those is using Darlington pair. In our earlier course EDC, we studied that Darlington pair gives us an input resistance that is beta 1 times beta 2 times this Re. And we also discussed in our ECD course, this course, a couple of lectures before. Rn is beta 1 times beta 2 times Re. So now we have product of beta that is very large compared to a single beta. So now we have a large value of Re. So if we replace this NPN with an NPN Darlington and this PNP with a PNP Darlington pair, that will solve the small Rin problem, right? So let's do that. Let's draw a Darlington based class AB push-pull amplifier. So what we have done is we have replaced this NPN transistor with this Darlington pair and a PNP transistor with this Darlington pair or type PNP. But instead of having two diodes, now we have four diodes. Why? Because we want this base emitter junction to be this voltage VB to be 1.4 times to be higher by 1.4 compared to this VE. So VB should be VE plus 1.4 to forward bias these two junctions, these two base emitter junctions. And similarly, we want this VE to be higher than this VB by 1.4 to make the base emitter junctions or emitter base junctions of Q3 and Q4 forward biased. So therefore we have these two resistors D1 and D2 for this Darlington pair and D3 and D4 for this PNP Darlington pair. That's the only modification that we have to make, in addition to replacing the single transistor with Darlington pair for this NPN and PNP. The remaining circuit is the same, and let's now compare the new circuit, this one using Darlington pair, with this old circuit, this one that is not using Darlington pair. Actually, we want to see how much is the benefit that we get in case of Darlington pair in this when we use Darlington pair. So what advantage do we have in case of Rn? So what we are going to do is we are assuming beta for each of these four transistors to be 50. And Re is approximately 1 ohm. R1 is 10K and R2 is 10K. So Rin should be beta 1 times beta 2 times RL in parallel with R1 in parallel with R2. So plugging all these values in, 50 times 50 makes is 2500. So this is actually the deciding factor, 2500. This product is the deciding factor. So that makes the Rn in place of R1 R2 we put 10K and 10K, and we get 4 kilo ohm resistor as Rn. So let's see what would this resistor be, Rn be, in case of in case of a simple class AB push-pull amplifier where we don't use Darlington pair. So let's compare it so that we may convince ourselves that Darlington pair offers better Rin. So that would be beta times Re plus RL in parallel with R1 in parallel with R2. So here we have only one beta because we are not using Darlington pair. So putting 50 Re1 RL is 8 ohms. RL is 8 ohms. I haven't mentioned it here, but it is 8 ohms. R1 is 10k RS. So RL is 8 ohms. I forgot to write it here. This is 8 ohm. So in parallel with R1 in parallel with R2 gives us 0.4k. So we see that Rin for the case when we use Darlington pair is approximately 10 times higher than the Rin that we have otherwise. So Darlington pair offers a good input resistance and it solves the last problem of class AB push-pull amplifier. So there is one other way we can use this Darlington pair in our class AB push-pull amplifier using Ziegler pair. Ziegler pair is a complementary Darlington pair. For this, the difference is that one of the two transistors that we use for a Ziegler pair is PNP and the other is NPN. In our previous case, that was not the case. For this Darlington pair, we have both NPN transistors. For this Darlington pair, we have both PNP transistors. So making this a PNP Darlington transistor and making this an NPN Darlington transistor. But for the Ziegler pair, we have one PNP and one NPN transistor. So what's the advantage for that? What's the advantage of using one PNP and one NPN transistor? Right, that is that to turn this transistor on, we have to keep this VB only 0.7 volt higher than this VE. So to turn this transistor pair on, we only need 0.7 volts. So that's the advantage. That's actually the advantage of using Ziegler pair, because for Ziegler pair, the complementary Darlington pair or Ziegler pair can be turned on for VBEs as small as 0.7 volt. Whereas for a conventional Darlington pair, we need to have 0.7 for this pacemaker junction to turn on this pacemaker junction and 0.7 volts to turn on this pacemaker junction. So in total, we need 1.4 volts to turn a Darlington pair on. But for a Ziegler pair, we need only 0.7 volt, and that is why we have only one diode D3 instead of having two diodes D3 and D4, like we had in case of the push-pull amplifier that we implemented using conventional Darlington pair. Here we have two diodes D3 and D4, but here we don't need two diodes, only one of them is enough. So only D3 is enough. So these are two advantages that we have, that we can gain using Ziegler pair. So these are two advantages. So I wanted to discuss advantages, and I wanted to tell you that Ziegler pair is also called complementary Darlington pair. That's all for this lecture, and with this lecture we have studied almost everything about class B and class AB amplifiers, right? And in the next lecture we will start studying class C power amplifiers. Thank you.